let's say that I'm on my kayak on the Connecticut River. Now, the Connecticut River runs roughly north-south. So I've indicated these blue parallel lines here to show the river. So we could say that this is the west side of the river, the west bank, and this is the east bank. And let's say that the river is flowing south like it does in the Connecticut with a velocity of 1 meter per second. And I'll give that a W, VW for water, all right? And then let's say that I'm crossing it from the west to the east, 2 meters per second. So this would be my velocity vector. All right, so I'm trying to end up over here, but the water is pushing me downward, so I'm really going to end up down here. So how far am I going to end up? So my ultimate velocity vector will look something like this. Okay, that will be my total. All right, so what is this distance here? What is that displacement that I'm going to be off by? So the total distance, all right, of me with respect to the Earth, all right, the Earth, the bank, is going to be the sum of the distance I travel with reference to the water. So me with reference to the water plus the distance that the water travels with reference to the Earth. All right, so how do we find that distance traveled? Well, distance is part of the velocity. Remember, velocity is position over the time interval. So if we solve for r, we get it's the velocity times the time interval. So I know that my velocity with respect to the water is 2 meters per second. What's the time interval? Well, how long does it take me to cross? If it's 100 meters wide and I'm going at 20 meters per second, well, we can solve for delta t over here. We'll get the distance divided by the velocity. All right, that's 100 meters divided by my speed of 2 meters per second. That means the time is 50 seconds it takes me to cross. Then we'll add the distance that the water moves with reference to the Earth. So that moves at 1 meter per second for that same 50 seconds. And I'm just going to insert an I hat here and a J hat here, just so I indicate which way is east, which way is south. All right, so I move 100, and my seconds cancel out, so I'm left with meters. All right, in the I hat direction, and 100 meters makes sense because that's the width of the river that I'm trying to cross. Plus 1 times 50 is 50. Seconds cancel out again. I'm left with meters. J hat. So that means I'm going to end up 50 meters south, downstream from where I intended to end up. Okay, so what actually is my velocity? So I'm rowing at 2 meters per second. The water's pushing me at 1 meter per second. So how do I find that? Well, I have a nice right triangle here. So I just need to say the Pythagorean theorem, v squared equals v me, right, squared plus the velocity of the water squared. All right, so my velocity was 2 meters per second squared plus the water's velocity was 1 meter per second squared. All right, if I take the square root of both sides, I'll say v is 2 squared is 4 meters squared per second squared plus 1 squared is 1 meter squared per second squared. All right, so that's a total of 5 meters squared per second squared, right? And the square root of 5 is about 2.2. And of course, I'm left with units of meters per second.